Yeah, today I'm going to talk about both, what is our organization's responsibility, but those of us in application development. And having, 3 decades building applications, I have quite a few opinions on this, but also as a leader of those applications and the responsibility as such. So let's go ahead and go to the next slide. Let's see if I can move it. Hold on. One second. Okay. All right. So, and Alexandria already introduced me, but let me go back one. I guess there's a bit of a lag. So yes, I've been with Schneider Electric for 14 years. We're a large industrial control system and energy management manufacturer of services solutions. We're global in nature, headquartered in Paris, France, but also I'm the author of the O'Reilly Media book. So if you have access to the O'Reilly Media platform, or you can find it on Amazon, it is out there and has a lot of different information in regards to it. And this information that I'm covering today, I talk a tiny bit about it, but this is all new content in the presentation. And so source code grows old. I think that I definitely mentioned in the book that part of the source code that I wrote back in the middle 1980s was for the paint.exe application that is still on Microsoft Windows computers. I worked at a company in Atlanta called Zsoft, and we sold our version of paint.exe to Microsoft, and then we went ahead and we're working on our next generation product called PC Paintbrush. And so that paint.exe code written in C a long time ago, we edited it with a VI editor. I'm sure lines of my code are still in there because, it still looks the same. I'm sure they haven't refactored it, but that is just, what happens with code that's out there. It lasts for a very long time. And so in this next picture, which you're not going to be able to read the graph, but I included a few details about it, about the millions of lines of code. So back in, the paint.exe, I don't remember the lines of code, but probably, 100,000, a couple 100,000. But we see MySQL being 12 million lines of code, Facebook being 62 million lines of code, Mac OS version 10.4, 80 million, 100 million for car software today, and then 2 billion lines of code for all of the different Google Internet Services platform. So imagine all of those lines of code that have been written over the years and decades. And as a software developer and leading thousands of delivery of projects and R&D folks, it is difficult to find somebody who loves to maintain older code. I think that in most cases, you've probably seen this in your companies, where when somebody new joins the organization, in order for them to understand the platforms that we're building, we put them on the responsibility of maintaining the older code. So they do bug fixes. They basically earn their stripes, as we may say in the US, to move on to newer projects by doing that maintenance. And sometimes some of that maintenance may be sent to different locations where the cost of having that software development is a bit lighter and lower than it is in, let's just say, higher cost countries. So maintaining all that code, honestly, does it get maintained, or is it just, let's just say, the heartbeat, we're just keeping it on life support? And I think that in most cases, that life support mentality, or that fear of breaking it, because you only want to fix what you have to, because you may not know exactly what it does. And this cartoon represents some of those details about what our responsibilities are. Of course, we're responsible for writing efficient and secure code, right? That's our job. And we should be testing and analyzing and scanning that code to make sure that it is efficient and secure as we're developing it. We need to comment and make sure that everybody understands what that code does on commit. And that last responsibility, it's the hard one, isn't it? Correcting defects and maintaining code. And this is where I'm going to stop for a bit and just talk about really the responsibility of ourselves as developers and then those of leadership. And so I don't have any slides that go too detailed into this because it's more of a conversation, and I can let you know how it happens from a product owner. And I'm sure you see this in your own companies, as I've seen over my several years, decades. So first off, I'm writing new code. I commit it. It's put into to the build, and hopefully it passes and everything's cool until it goes to testing. And I should have, in theory, been working a lot on unit tests to make sure that my code, and I'll talk about that a bit later, our responsibilities. But from a management responsibility, they're focused on, I would say most of the time, what is the next customer features? What do we need to deliver? What do we need to do to hit our goals and ambitions? And so maintenance of that, which would include cybersecurity maintenance and activities and vulnerability management, is not allocated generally in that. And so, we've run into, as an industry worldwide, from a software development standpoint, having to not only maintain our code for bug fixes, but also now from a cybersecurity. And I've read different details about, the risk, the amount of time it takes to now keep a application up to date. Some estimates are between 10 to 20% in order, depending on how much open source is used, how much regression and interoperability testing you have to do just to maintain the cybersecurity posture. And also, you may have to add additional cybersecurity features. Products developed 15 years ago, probably had admin as a hard-coded password and username, and those have to be removed from code that is still live, essentially, out there with products that are still being maintained or multi-generational products. And so it is the responsibility of the management teams to allocate time to be able to do those cybersecurity fixes. But my premise here is really the responsibility of us as team members. What do we have a responsibility for? And so I'm going to show you the correlation now of what's happening in certain parts of the industry, especially in engineering circles, when it comes to critical infrastructure and some cyber physical systems that are being developed for defense industrial-based programs, weapons systems, things like that from different global countries. And the reason why I have this insight into it, because my company ourselves does not develop any of those systems. We are a commercial off-the-shelf provider of products. But I've been working with the National Society of Professional Engineers in the US for a program that I'm going to talk about. So let's just talk about, for example, the responsibilities of defined software engineer. So I think the terms software engineer and software developer have been used interchangeably by a lot of people. And as a software computer science major and software developer by training, I did not have the true engineering professional certification of professional engineers that my university friends who were electrical engineers or mechanical engineers or nuclear engineers had to go through for certification of their skill set and for them to work in certain industries. So for example, the mechanical engineers that were working on bridge systems and designing certain things, they had different professional certifications that they had to do to be able to work on certain projects, whether they're building roads or building buildings or building certain products, that they had to have that skill set. Definitely electrical engineers working with so many different codified laws on how to work with electricity and power. That engineering discipline has had certifications for a long time, as we've seen some other certifications. But the word engineer is a tricky subject. So the IEEE Association has a code of ethics for software engineers. And so I'm sure you've had some time to look at this. And what this is talking about is what is a software engineer truly responsible for. So if your title is software developer or software engineer, really from an engineer standpoint, there is an association that you have a responsibility and a duty that I'll be talking about in just a moment. So see these, which is, making sure that you are working with and having those appropriate items where you're ensuring that the product and related modifications meet the highest professional standards possible, and that you're using your judgment, and that software engineering managers and leaders shall subscribe to and promote ethical approach to the management of software development and maintenance. And see how it says and maintenance? And that's the key thing is, and I'll talk about sort of where this wave of engineering and code of ethics is going. And so there is something that I've been working with, and I was brought into it because of my book, Software Supply Chain Security, and my experience on the commercial side. There is a certification that I was part of designing, not in detail. I did not have the bandwidth to be able to work on the actual exam questions, but I'm part of the committee for the System Software Integrator SSI certification. And you'll see here where it talks about this certification, and it's for different, it's not just for software engineers, but it's also for program managers, quality assurance, systems integration, and risk mitigation. And the type of people who might be taking this, I would definitely say would have an engineering mindset and must conform and agree to a code of ethics, because this is a professional engineer certification. And what is happening is that in certain, so the groups that really initiated and kicked this off were those in some of the defense industries, and they were looking for a way to certify their software developers and software engineers in that same level of professional engineering and code of ethics. And with that, they needed to have the background that's more than just what we might have taken in school for university on computer science. So that includes a lot of cybersecurity, but it also includes the integration aspect, because when you're working with critical infrastructure and cyber physical systems, such as a fighter jet or a weapon system or anything of that nature, they wanted a seasoned but also educated, whether it be through their own education and certification, professional that is assigned to those projects. And so the University of Florida, various universities in Florida, along with the NSPE, are working and they're piloting this project and this certification. So if you Google it, I've got a link down below. You can see that it's 50% off in the pilot phase of this certification, which there are, not even yet a full handful out there. Until the pilot finishes, the first group won't be fully certified, but we're seeking people who will pilot this to be able to demonstrate that this is an additional layer. So I myself have a professional certification called CSSLP, which is more about the software security lifecycle practitioner. But this goes further when it's talking about cyber physical systems and the integration layer, which goes into a lot of the supply chain topics that I work on, which is when you're putting together multiple different products and components into a system that has to do an activity, there's a lot of considerations. So for example, those of you in application development that are developing threat models, you're not only doing a threat modeling on your component, but on the entire system, which can be quite extensive. And so there's all these different topics inside of this certification. So now I'm going to talk about this duty of care. So if I, took this certification and agreed to the code of ethics, I would be responsible for what is called duty of care. And honestly, this is where all software developers should be following a duty of care. And that's a legal obligation that's imposed on an individual. So, not just behind your corporate liability or software liability. And I'll talk about software liability in just a moment. But this means that a software developer, whether they're creating some open source or some other, would need to be responsible for that duty of care. And in that standpoint, that's the same as an engineer. So if a bridge is being built and you have different engineers working on that, not only is there a project company that's probably designing that, but also those engineers have to be certified and that they are holding themselves to the most the top level standards as they're designing this project. And that's where on these mission critical systems that are being developed for different government entities around the world, they're looking for a higher level of standards for that software professional. But we're also seeing that in different areas for the, let's just say the industries that have software liability, that veil that software is behind is where the US government and other governments are trying to break through that veil, both to say there is liability, but can it be done at the individual level? That hasn't been proven yet. But it'll be interesting to watch this, I think, over the next 5 to 10 years. So what are some practical approaches to duty of care? And this is really where we're taking this whole measure of responsibility, is bringing that awareness of duty of care to your organizational management. So let's say whether you're a software developer, a software engineer, or you're a team lead, or you're a manager, you should be taking this accountability that you yourself should have to your organization to say, we have a responsibility and a duty that is called on and required of us that supersedes in all cases really, deliverable deadlines. So, I mean, I've seen many projects, it's like, okay, whatever you have ready by October 30th, we'll go ahead and release that. But that doesn't give you the balance that's needed for that duty of care. So bringing that awareness and that responsibility, which honestly, I've seen many people, they're concerned about it. And, they want their voice to be heard, and they have this passion for making sure that the code is error-free, and that from a testing standpoint and a quality perspective, that it's there. And then, so how are some of the ways to then do that? Well, I've read different approaches, and I've seen different approaches. And either if you're, and I'm going from the agile kind of discussion here. Creating user stories or add defects to the product backlog, whichever the way your company allows it. But no matter what, they have to be prioritized to the right level. So making sure, again, that your product owners really understand this importance and that they are responsible also for this duty of care. It's not just the developers. It's those making the key decisions that they are accountable in regards to the level of errors, not only those who wrote, those lines of code, but those who are actually saying, here's the priority for doing that work. That is often the product owner and the engineering management, and they need to be aware of that responsibility. And one of the best ways is, in addition to this duty of care, is having the product and AppSec training for everyone. And leading 14,000 people in R&D and owning all of the product security training curriculum, it was required for every single individual. It wasn't just software developers. And this is something that I'm very, very passionate about, is that if someone understands the cybersecurity risks, that not from a technical nature, but what the impact it could have, that they have a responsibility to make that educated decision on whether or not to accept this. They are accountable. It's not just at the development layer. And the only way to really understand that is to understand the cybersecurity risk and product risks. And also some ways to enhance this duty of care is to insist on better unit testing and test automation. That can generally speed up, for example, if you're upgrading the library from one version to another, so an open source library, because it has some vulnerabilities that are critical and high, and you need to be moving to, let's say, an N-2 version, maybe not the latest because of, additional cybersecurity risks. But having that be part of the test automation so that it can validate that there's no issues in regard to that library upgrade is really important. And that can enhance the accountability of the entire team to be able to say, we've passed. And I think most people who've done this, but I still see, especially in, let's just say, startup companies and such, that there's not the level of test automation and unit testing because you're trying to get out that proof of concept out really quick to show proof of value. And there are definitely technologies now that can create those unit tests and test automation based off of what they can see. There's scanning tools that can judge that analysis. Another thing that I love to do is capture the flag events to learn more about threat techniques, because if you've actually experienced and done your own ethical hacking, you're much more inclined to realize it as you're walking along. So, let's just take a simple example. If every door you've ever walked through did not have a lock, you wouldn't think to put on a lock. But if you were, we do have that concept of, hey, there's locks on these doors because our habits have shown us locks can potentially prevent some kind of threat or, some kind of theft. And so the same thing happens when we do capture the flag events. So also leverage these next pieces as co-pilots, that you can do a lot more to recommend fixes. And I've seen some amazing startup companies and technologies, and you can alleviate and reduce the maintenance time that's your responsibility by leveraging that and having the right tools in place. Just couldn't get away without mentioning code reviews. Again, I've seen younger companies, they skip the code reviews because it's only just a few people. Doing those code reviews, you will always see something, and it'll spur conversation. And that conversation is really important. Did you think about this? Should we consider this? And then you put it, and then a bug bash, whether or not you're doing it as a single sprint or adding it on. I do like the bug bash and the maintenance sprints and the tech debt sprints to really make a difference in all of this. So for some key takeaways, before I take any questions, just in summary, there's a lot of code in the world, and a lot of code is not being maintained. And as developers, we know what we need to do, but we probably aren't doing all the necessary things. And that engineers are following a code of practice, but as software developers, we need to become software engineers in the true sense. Software liability is changing, and soon developers may be held personally accountable, and duty of care must be taken seriously by software developers and, of course, their engineering management. This includes making those organizational changes and requiring application security. And so that's what I wanted to talk about and really challenge you to think about this as an important topic. I know it's not sexy, to maintain code or do anything of that, but it is highly important, especially in our ever-changing world of cybersecurity threats. And feel free to connect with me on LinkedIn, and there's a link right there. And I promised you it's safe. I checked it again right before I sent the presentation, and it goes to the O'Reilly Media page, which either links you to the O'Reilly Media platform or to Amazon if you're interested in purchasing the book. So I think if there's any questions, I'd be happy to take them.
I think there is a couple of questions.
Okay.
Thank you already so much, Carrie, for your presentation. It was very insightful. I think we have someone also who is disagreeing with you.
That's fine.
Let's start with the question of David.
Okay.
Do you expect we'll see more companies held to software liability standards? For example, large enterprises that lost billions to the CrowdStrike outage this summer?
Yes. Having a lot of internal conversations with U.S. government officials, like being at the White House, they were very frustrated after the Outlook logging event, of which the government was impacted of that. And then when with SolarWinds, and after that, more recently, CrowdStrike, yes. In fact, if you look at the U.S. National Cybersecurity Strategy, when they released it a couple years back, they talk specifically about software liability. They've put professors and think tanks on this conversation. So I do expect to see that liability change, because they're not the only ones talking about it. I'm hearing it from other government officials around the world. So I think that those legal defenses that we've had in the past, especially in contracts with governments, is going to be changing.
Sure. And there is feedback, I would say, from Nathaniel. I can see in the public chat. Not to disagree, but there is fundamental difference.
Well, that was the whole point, right? You wanted something controversial for this wonderful conference.
For sure.
And I'm like, this is a controversial topic.
Yeah.
So definitely bring it back up so that I can read all of it.
I think you can find it in
I can see
chat.
it. So fundamental difference between software engineering and other engineering practices, but I don't think the legal applications are really feasible. Yes, I agree. The legal obligations are going to be extremely difficult. I work with the open source world, the accountability for that. You may not know, if my, handle on GitHub is something else, and so on and such. So unless somebody is writing 100% proprietary code, the legal obligations for that engineer who made the selection and that software developer and so on and so forth, let alone all the traceability we have and the provenance of when we made that decision and who made that decision, it's much more complicated than an engineer who's designing and like, here's blueprint number 1, who drew that wall to be 2 inches versus 3 inches. I mean, they still have some, and it's a much smaller thing. When you're incorporating and having systems with millions of lines of code, yes, I am very interested to see how the government is going to want to include some of this from an engineering perspective. So from what I understand, most of it will be in a contractual nature. You need to have somebody with this certification on a contract. So that'll be how it goes. That person, though, will have the accountability. And that's a key thing, is by being an engineer, they are the ones accountable, which means that they are thought to, in theory, they should be making sure that there's no cybersecurity risks almost, and that's impossible, in my opinion. So I'm very interested to see how this plays out. I agree. This is totally different in many different respects and going to be a challenge. However, they're trying to start somewhere. And so that's why they're really looking at, and they're talking to they're going to all the IEEE conferences and different areas, things that typical software developers don't necessarily attend.
Yeah, makes sense. I think we're at the end of the time that's available. Thank you so much, Cassie, for your presentations. If there are any questions, well, maybe I'll try when I upload the recordings on YouTube to address them afterwards. But yeah, we're at the time. Thank you so much for your time, and I actually like that it provoked, some conversation in the chat. No worries, Nathaniel. We actually prefer strong opinions, so that was very nice. Thank you so much, Cassie, and enjoy your day.
Thank you for having me.